Okay, we're going to start talking about Chapter 1, Section 1.4, Sets, Inequalities, and Interval Notation. So the goals of this section are to determine whether a given number is a solution of an inequality, to write interval notation for the solution set or the graph of an inequality, solve an inequality using the addition principle and the multiplication principle, and then graph the inequality, and solve applied problems translating to inequalities. So what is an inequality? We know what an equal sign is, but an inequality is something that has these symbols in it right here. This one's your less than, greater than, less than, or equal to, and this line's underneath it, greater than or equal to, and this crazy looking thing means not equal to. So an example of inequalities are something that has one of these signs in the problem. So like this 3x plus 2 is greater than 7, c is less than or equal to 7, 4x minus 6 is not equal to 3. Those are inequalities, something that has one of these signs in it. So how do you find the solution to an inequality? Any replacement or value for the variable that makes an inequality true is called a solution of the inequality. The set of solutions is called the solution set. When all the solutions of an inequality have been found, we say that we have solved the inequality. So determine whether 5 is a solution to this inequality. Okay, so I'm going to write this over here. 3x plus 2 is greater than 7. And they're asking us if 5 is a solution. So what we're going to need to do is plug in for 5 for x and see if that makes this statement true or false. Now, once again, when I plug in a number, I always put it in parentheses because it helps me to get the right answer. A lot of times when a number is negative and you don't plug it in parentheses, when you're trying to square it or things like that, it'll throw you off and give you the wrong answer, especially if you're using a calculator. So when I plug something in, I always put it in parentheses. While it's not always necessary, but okay. So 3 times 5 is 15 plus 2 is 17. Okay, and then what you want to ask yourself is this true? Is 17 greater than 7? Well, yes, it's true. And because it's true, 5 is a solution to this inequality right here. Okay? So the graph of an inequality is a visual representation of the inequality solution set. An inequality in one variable can be graphed on a number line. Graph x is less than 2 on a number line. Okay, well, let's look at that. So the number line kind of looks like this. So just draw some lines on here. Okay, so let's say this is negative 2, negative 1, 0, 1, 2, 3, 4. Now this statement says x is less than 2. So I know that I've got an issue at 2. Can it be equal to 2? No. Okay, and so since it cannot be equal to 2, I'm going to put an open circle there. If it had the line underneath it, right here, if it said less than or equal to 2, I would fill in that circle, but it doesn't have that. And I want all the numbers that are less than 2 that would work, right? Negative 2 is less than 2, negative 1 is less than 2, 0, 1, and 2, okay? Another way to write that on the number line is sometimes, instead of doing open circles and closed circles, okay, for an open circle, they'll write like a parentheses, and they'll color it in this way. If it had the equal to part in there, they would do a bracket instead. And we'll go over some examples of both of those in just a minute. Okay, set builder notation is another way to write the same representation as this. So the way that you write set builder notation is you say all x's such that x is less than 2. So it's just a fancy way for writing this. And this, not very pretty, needs to look more like this. Okay, so there's set builder notation. That's what that looks like. Interval notation. Another way to write solutions of an inequality in one variable is to use interval notation. Interval notation uses parentheses and brackets. Okay, if A and B are real numbers such that A is less than B, we define the open interval, and it's open because it has parentheses instead of brackets, A to B, as a set of all numbers x for which x is between A and B. Okay, and I feel like for most of you guys, that's just a whole lot of blah, 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 because it's hard. All those math words are kind of hard to understand. So what does that really mean? Okay, so basically they're saying if you've got this, that there is some, whatever we're trying to contain is in between A and B, but it can't be equal to A and B, or else those would be brackets. In set builder notation, you would write that like this: x is in between A and B, not equal to A and B. And on the number line, it would look like this. So there would be some x somewhere in here that fits. Could be anywhere in that group. Now, if you'll notice, this is different because now we don't have those parentheses. We actually have the brackets. And what's changed in this? Well, the thing that's changed is now we have these equal to, less than or equal to. The one above, when it was just parentheses, we just had the less than signs. So when it's brackets, it could be, it's adding on the equal to part. And so saying the same thing, that the x is in here somewhere. But because it has the equal to parts, x could be A and x could be B because we have the equal to parts as well. So it could be anywhere in there, and it also could be equal to A or B. That's what the brackets versus the parentheses mean. Okay, there are two types of half-open intervals defined as followed. Okay, so we talked about the bracket. Remember, the bracket means it could be equal to, and we talked about the parentheses, which means it's not equal to. Okay, so this kind of makes sense. A is, so there's an x. X can be, if you read this backwards, x can be greater than A. So we've got an x in here somewhere. It can be greater than A. It's not equal to because there's a parentheses there. And x is less than or equal to B, which means that x could actually be B. So it's in this place or it's equal to B. Okay. On this one, it says A is less than or equal to x, or x is greater than, if we go backwards, x is greater than or equal to A. So now we've got x in here somewhere. Or it could be equal because we have a bracket, or it could be equal to x, but x has to be less than B. X could be all the way over here, right? All the way as close as we could possibly get to B. But x will never be B because it's got to be less than. It doesn't have the equal to part, and that's why we've got the parentheses there instead of the bracket. We use symbols, and most of you guys probably know what this is, an infinity and negative infinity to represent positive and negative infinity, respectively. Thus, the notation, open parentheses, right, A to infinity represents the set of all numbers greater than A, and negative infinity to A represents the set of numbers less than A. Okay, so if I saw this, I would say, well, it's not equal to A, but it could be any number all the way to infinity. So x could be 3054, right? It could be any number that's bigger than A all the way to infinity. On this one, from negative infinity to A, x could be anything like negative 3 million even, anything down this way, but it can't be equal to A, all the way up to A, right? The notations negative infinity to A, closed, and close bracket A to infinity are used when we want to include the endpoint. In other words, it could be equal to A. Okay, and we're going to work several examples to help you kind of wrap your mind around this. Okay, so this says to write interval notation for the given set, and I'm also going to draw a number line, okay? So I'm going to draw a number line first because I think that helps you guys kind of get your mind wrapped around this. So we know that we're looking at something, I'm not going to draw everything, but we're looking at something that is happening between 3 and 8, okay? And is it equal to 3 or 8? No, because it doesn't have the equal to sign under. And remember that if it's not equal to, it gets the parentheses. So we're talking about any x, any number that happens between 3 or 8, but not equal to them. And this actually could go on 8, okay? So it could be 4, right? If you'll draw a number line first, it kind of helps you write interval notation, because the way that we would do interval notation is 3 to 8. Okay, so on this one, if we draw a number line, I only see one number here that we're talking about, and it's 4. Okay, so all x's that are greater than or equal to, that's important, so it doesn't get a parentheses there, it gets a bracket. And see how it's pointing to the away from the 4? So we want all things that are, now it could be equal to 4 or could be anything bigger than 4, like 10, okay? And I also probably should have colored in, these are the numbers that we're talking about right here. So interval notation, if you read this number line from left to right, it makes it really easy for you. 4 to, well, when does this stop? Never, right? So infinity, and infinity always gets a parentheses. Okay. The addition principle for inequalities is stated right here. Okay, so it's asking us basically to work some problems. So if I want to solve this, x plus 6 is greater than 2. Really, it's just about, there's one exception, and we'll talk about that exception in a little bit, but really it's just like working this problem if there was an equal sign. So I need to go to the side with the x and get rid of everything that's connected to the x. So how do you get rid of a plus 6? Well, we would need to subtract 6, but if you subtract 6 on this side of the inequality, you're going to have to subtract 6 on this side. So that's going to give me, with x is 6 minus 6 is 0, greater than 2 minus 6 is negative 4. Okay? It's telling me to graph the solution. I'm going to graph it on a number line. Just for time's sake, I'm not going to write every single number on my number line, but at negative 4, that's going to be my important point. It doesn't have the equal to part, right? It's everything that is greater than but not equal to, so I need a parentheses right here. If it's bigger than negative 4, I'm going to color in the right side. Okay, interval notation for this would be negative 4 to infinity. Well, let's just see. Let's try a number that's negative 4 to infinity. Maybe 0, right? 0 would be included in those set of numbers. Let's just see. 0 plus 6 is 6. Is 6 greater than 2? Yes. Okay, so I could kind of self-check. Okay, I'm going to write this so we just have a little bit more room. 4x minus 1 is less than or equal to 3x minus 4. Okay, now let's recall solving regular problems with equal signs. Remember that you want to get rid of any parentheses you have, right? But we don't have any. And then you want to make sure your x's are on the same side, okay? So I either have to move 4x or move 3x. If I subtract 4x, it's going to give me a negative number, and there's absolutely nothing wrong with that, but I really don't want to have to deal with that. So I'm going to subtract 3x from both sides. Okay, 4x minus 3x is going to give me 1x minus 1 is less than or equal to, this turns into 0, 3x minus 3x minus, when I bring down my negative 4, right? So now I've got my x's on the same side. I want to get rid of the thing that's not connected to the x, which is a negative 1. So we're going to add 1 1x is less than or equal to negative 4 plus 1, which is negative 3. Okay, do I really need 1 times x? No. 1 times x is just x. 1 times anything is just itself, right? So my final answer is this. I have the place where I'm going to have something happening is at negative 3. If you always write the x in the front, then your colored in part is always going to be whichever way the arrow is pointing. Okay, and so x is less than or equal to negative 3. So that means since it's equal to, I'm going to get a bracket. And you'll notice I'm turning it this way because it's all the x's that are less than negative 3, like negative 4 and negative 5, negative 7, right? So those are the solutions to this. If I plugged in one of those numbers, it would make this true. So let's do that. Let's say, so we think, let's say, well, is x equals negative 7 an answer to this? Let's just try it. So 4 times negative 7, all I'm doing is plugging in whatever for x, I'm plugging in negative 7 every time I see an x, minus 1. And remember, when I plug things in, I put it in parentheses. It helps me from making a mistake like I just did right there. So, okay, 4 times negative 7 is negative 28. Negative 28 minus 1 is negative 29. Is negative 29 less than 3 times negative 7 is negative 21, minus 4, negative 25. Well, is negative 29 farther down the number line than negative 25? Yes, it's less than, so that works, okay? So I could have checked other numbers besides negative 7, but they needed to be these numbers that are colored in this way, right? The next one would be negative 4, negative 5, and etc. So you also need to know about the multiplication principle of inequalities. Now, this is going to be a little bit different. This is where the trick comes in. It makes it a little bit, complicates things a little bit. So if we look at this example, okay, this one's going to be easy to solve. To get rid of a 7 times x, we're going to want to divide by 7. On both sides, because the opposite of multiplication is division. 7 divided by 7 is 1. And then 35 divided by 7 is 5. So they also want me to graph that. So x is less than or equal to 5. It would get a bracket because it has the equal sign, and everything less than or equal to 5 would be this way. So if I wanted to write that interval notation, I would say negative infinity because I'm always going to read from left to right. So if you keep that arrow keeps going this way, it's going to be negative infinity to 5, close bracket. Okay, that would solve this problem. Any numbers that are 5 or less. Okay, now here's where the problem is. If you have to star this, draw circles around it. This is the only way that this is different. If you have to multiply or divide by a negative number, then you have to switch your sign or you're going to get the wrong answer. Okay, this right here will make you miss a lot of problems. So far, we've not had to multiply or divide by a negative number, but we're fixing to have to. Okay, so this is negative 4 times y. How do you get rid of a negative 4 times? Well, you're going, the opposite of times is division. So we're going to need to divide by negative 4 on both sides. These will cancel out because negative 4 divided by negative 4 is 1. And we divided by a negative number. So when I say switch your sign, it was less than, now it becomes greater than. If it had an equal to, that would still say 20 divided by negative 4 is negative 5. Okay, so if I want to graph that at negative 5, it would be a parentheses because it doesn't have the equal to, but it's everything greater than -5 are going to be the answers. We could go into talking about why that is. But for right now, we're just going to cover this part. So I could even check and make sure this is going to work. What's the number that's greater than -5? Maybe -4. So if I plug in -4 times -4 just to see if I'm right. -4 times -4 is -16. Is -16 less than 20? Yes. Okay. So what about this one right here? We don't have any parentheses to get rid of, but when you go to the next step, we do have x's on both sides. So we're going to have to get rid of an x. So I would rather subtract one x. Now I'm subtracting an x. Am I multiplying or dividing by anything? No. So I don't really have to worry about switching my sign. 3x, take away an x is 2x. X minus x is nothing. Bring down my 7. Okay, we're going to add 3. So 2x is greater than 7 plus 3, which is 4. Okay, go to the side with the x on it. How do you get rid of a 2 times x? Well, the opposite of times is going to be dividing, and we're dividing by 2. Now, if it had been a -2, this sign would need to switch. 2 divided by 2 is 1, and so we're going to get x is greater than 2. We want to graph that. We've got 2 parentheses because it's not equal to, and interval notation would be 2, right? If we read this from left to right, 2 to infinity. Okay. Oh, this one looks complicated, right? Okay. We've got parentheses, so this will kind of review us over what we did before when we were just solving equations. If we've got parentheses, we want to get rid of them, so we need to use the distributive property and multiply out. Okay, I'm gonna do that, but I'm gonna start writing up here so I've got a little bit more room to show you. So 5 times x is 5x. 5 times -3, this whole thing goes together, is -15, or -15. Negative and minus are the same thing. Minus 7x is greater than or equal to 4 times x. 4 times -3 is -12 plus 9. Okay, so we got rid of the parentheses. Now, if you'll recall, the next step was to combine like terms. So 5x and -7x could go together. 5 minus 7 is going to be -2x, and we still have that minus 15. 4x doesn't have, there's no other x's over here, so it's 4x. But the -12 plus 9, -12 plus 9 is -3. Now remember, we can't have x's on both sides, so we got rid of the parentheses, we combined like terms. Now we want to get all of our x's on the same side. And just so that I can show you another example of one where the sign changes, I'm going to subtract 4x from both sides instead of adding 2x. But you absolutely could have added 2x, that would have been fine. So -6x minus 15 is greater than or equal to -3. We go to the side with the x on it and still keep working. How do you get rid of a minus 15? And add 15. We still have not multiplied or divided by a negative number. That is usually going to be your very last step if that happens. So -6x is greater than or equal to, this turned into 0, correct? -3 plus 15 is 12. And here we go. We need, it's -6 times x, so we're going to need to divide by -6 on both sides. These are going to cancel out. We're going to get x, but since we divided by -6, we're going to go from a greater than to a less than or equal to. 12 divided by -6 is -2. So on the number line, we've got -2. We've got everything that's less than or equal to. So all of these numbers down here would be less than or equal to. And to write interval notation, you're always going to go from left to right, just like you're reading a book. Well, all this is colored in down here. So that number, what number can it go to? Negative infinity, all the way up to 2, and then it stops. It could be equal to 2, right? But nothing bigger. Just remember that we had to change our sign when you multiply or divide by a negative number when you're solving your problem. So when we're talking about inequalities, that's a big time where people really get confused about wording. So this is a good little guide. Is at least needs to be greater than or equal to. Is at most less than or equal to. Cannot exceed less than or equal to. Must exceed greater than. Is in between. No more than, no less than. So these would kind of help you if you have word problems that are in your practice, how to set them up. Okay, translating at least and at most. Here's some examples of how to do that. So here's our last problem. Save a Lot offers 2 different checking account plans. Plan A charges 25 cents per check, where Plan B charges $3 per month plus 5 cents per check. For what numbers of checks per month will Plan A cost less? Okay, so we want to know, when is Plan A less than Plan B? Okay, so we're just going to assume that we're only talking about 1 month. So our variable here, X, is going to be the number of checks. That's the only thing that can change. So on Plan A, basically we know that it cost us 25 cents per check. Plan B, well, they're going to charge you $3 up front, but then they're going to only charge you 5 cents for every check you write. So there would be our 2 inequalities. So it says, for what number of months of checks per month will Plan A, well, we know something about Plan A. Plan A is 25 cents per check. When is that going to be less than Plan B? And this is Plan B. Okay, so we've got an inequality to solve. We've got x's on both sides. Would it be a good idea to subtract 0.25x? It's not a terrible idea, but a lot of people get confused when they're left with nothing over here. So I'm actually going to subtract 0.05x to get all of my x's on the same side. All of my x's from Texas, just joking. So 25 cents minus 5 cents is going to give me 20 cents times x is less than 3. I'm going to need to divide by, because we've got multiplication, so the opposite of multiplication is division to get rid of that. And so x is less than, I didn't divide by a negative 0.20, I divided by a positive 0.20, so my sign stays the same. And that's going to be 15. So what does that mean, right? What does that mean in this problem? Well, for what numbers of checks per month will Plan A cost less? So if I'm a person who only writes 5 checks a month, is 5 less than 15? Yes, that's good. If I write 15 checks though, I need to go with Plan B because it's going to be cheaper. Okay, because anything less than 15, let's just try real quick. Plan B should be more, or should be a better deal if we go over or equal to 15. So let's just say, well, what happens if I write 16 checks? Well, that's going to be, for Plan A, that's going to be 25 cents times 16. For Plan B, that's going to be 3. And what we're trying to say is we think it's Plan B is going to be better because Plan A is better for anything less than 15, and we've chosen 16. So 25 cents times 16 This is going to give me $4, right? And 3 plus 5 cents times 16, $3.80. So this would be the better deal if we have to go 15 or over. Okay. So that's it for 1.4. Feel free to contact me with any questions.